There's some people in Africa who don't look like each other, who are genealogically more closely connected. Okay? Depending on what kind of data you use, this uses traditional blood groups, you know, ABO, your blood type, and proteins in your blood, and then they did an analysis and they got clustering. And when they did it this way with the blood groups, they had the Africans and the Europeans were more similar to each other, and the people from Australia and North America and India were more similar to each other based on these genetic characters from the blood. But when they did cranial studies, they found that people from Papua New Guinea and the Australian Aborigines and certain Africans clustered together, and people from North America and Chinese, Japanese, people from Asia, Polynesia, that they clustered together. Now, which one is the truth? This is some old data. I see people looking. These are studies that were done when many people here were probably quite small. But anyway, there was a conflict here. There's conflict here. All of this is science. All of this is science. This is blood groups, you know, blood type, you know, proteins in the blood. And these are studies from the skeleton. The computer generated both of them. The data are real. Which one tells the truth? I put this up here to just let you know that you probably always need a model of interpretation based on wider sets of data. And in the current era, it's probably true that the DNA sequence data for certain markers will give you a tree that's different from both of these, and that you need a model rooted in concepts about African diversity to really understand it. Okay? Now, when it comes to Egypt, there's been a lot of previous work, some of it done right here on the Cambridge collection. Very famous study, Mukherjee et al., 1955, with Professor Trevor, who was here at Cambridge Department of Physical Anthropology. Overall, if you looked at all of these studies, none of these studies will actually show or suggest, with the exception of a few, that the Nile Valley people, called the Egyptians, were from any place else but Northeast Africa. Okay? There are other studies done with dental work and limb ratio. We talked about tropical body plan. And this is what I mean when you talk about in the state of our current knowledge. We have to understand there's a long presence of modern people in Africa. The coalescence times, the times to which you get to a common ancestor for many molecules, is so old that it generally places many of them in Africa, but not all of them. We have fossils all over in Africa. In Algeria, it's 60,000 years BP, but we have other fossils that have been dated that are essentially modern humans to around 190,000 years ago. The northeast quadrant of Africa seems to contain a subset of wider variation in Africa, and maybe the rest of the world contains a subset of this. In Africa, you have different ecozones, different demographic histories, and therefore we should expect a large amount of variability. Now, the methods that have generally been used, especially on skeletons, include these different methods that are involved. In one case, just looking at aspects of the anatomy, we call that a morphological approach. Not commonly used anymore, but in the past it was quite common. Now we use these other statistics that are usually based on measurements. Okay, some are more valid than others, we believe, from a mathematical point of view. Although sometimes you get very similar results no matter what you do. This is a human skull, and these characteristics that are shown here are called non-metric traits or traits, and these are just basically anatomical variations. These traits are sometimes called epigenetic, and many people believe that, at least for certain circumstances, that using these traits are sort of like using DNA from the skeleton. My own opinion about any of this kind of research is that at a certain level and local in restricted time frames and in local areas, I think that these methods are very valuable. When you start doing global things, you have to be very careful about your traits. You're going to get some parallel examples of what might be called groupings based on parallel evolution, like we saw with the Australians and New Guineans clustering together with certain Africans. In Egypt, we have, as I said, a long history of human habitation. Not a lot of fossils, but things going back to 55,000 years ago, which according to some geneticists is before the period of time that modern humans left Africa, at least through the northern exit. So we've had people there. So any idea that you had to populate Egypt from the Near East even 50, 60,000 years ago is not necessary. There have always been migrations back and forth, but to explain super-Saharan Africa, as I like to say, based on migrations from Eurasia is not well-founded. The Nazlik-Cotter specimen that I just mentioned here before, in one study by Gunther Brauer, plotted in a multi-discriminant analysis, plots with, quote, modern sub-Saharan Africans, but very near the line. I'm suspect of doing certain things with old specimens in this manner, but nevertheless, and in another study using a different set of variables, we see overlap in multiple directions. Number one, there's a lot of overlap in the middle. That's the important thing to understand. The crania from Dar es Sultan 5 dates to around 60,000 years ago. It has clustered with a group of Upper Paleolithic European skulls, as well as overlapping with North Africa. Only problem with 60,000 years ago and these Upper Paleolithic skulls, I mean, what's the problem with that? Let me ask you. They have material from Upper Paleolithic Europe, and they have this Dar es Sultan cranium or partial cranium, which is probably about 60,000 years old, and it's clustering with the Upper Paleolithic Europeans. So does that mean that it came from Europe? That would be our reflex, right? Does it mean? You can talk. No. Why not?
Because, you know, if it came out of Africa.
Huh?
If it came out of Africa.
Well, no, but I want you to answer this a very specific way. We have Upper Paleolithic European material, and we have this specimen that's 60,000 years old, and from North Africa, and it's clustering, it's grouping with Upper Paleolithic Europeans. So did it come from Upper Paleolithic means modern people, but the rest of these specimens, I can tell you in this study, came from Europe. So does it mean that Dar es Sultan came from Europe? It's clustering with them. Come on, we got Cambridge students here, right? PhD, master students, somebody? Oh no, people are shaking their, oh, good. There were no modern people in Europe 60,000 years ago. There were no modern people in Europe 60,000 years ago. So the fact that it clusters with them cannot be used, now you wait, to say that it came from Europe, because there was nobody in Europe for it to come from. The issue of when similarity means genealogy is always the issue in these kinds of studies. I don't care what the data are, with the possible exception of certain kinds of Y chromosome data and the mitochondrial DNA from women. Now, when it comes to Egyptian crania, the kinds of descriptions that used to be used, you know, in early days, good Brits, you know, Cambridge, Oxford guys, you know, talked about the pre-dynastic race of Egypt. They say, in the main, a blending of various proportion of Semite and Negro. And this is from an old book, The Earliest Inhabitants of Abydos. Well, what's very interesting about that is this is from a what? Typological perspective. You get something that's in the middle that seems to have different traits. Well, I would argue no, it's not a blending of anything. It's just own people that from a biogeographical perspective evolved right there in Northeast Africa. But this is what happens when you have a preconception about human variation being digitalized. So when you see something in the middle, a long time ago, you assume that it has to be the result of certain kind of mixture. Sometimes this might be true, but you can't prove it in a case like this, you know. And then